Our presenters today are Frank Mohr and Jason Klotz from Caterpillar. Please welcome me. No, please join me in welcoming them.
Good afternoon, everyone. As Kat said, my name is Frank Mohr. I'm an engineering specialist at Caterpillar. I've been with Caterpillar 17 years. I have design control of large wheel loader operator stations. When it comes to the electrical install, that's the one. Those of you that don't know the equipment, the big yellow piece of equipment right there on the screen. I also teach engineers how to use the cabling module and Creo schematics and integrate new acquisitions into the Caterpillar way of processes. There you go.
Hi, I'm Jason Klotz. I've been at Caterpillar for 8 years as a senior IT analyst. I have a team of software developers that use the PTC Toolkit API in order to create auxiliary applications for Creo, parametric, and schematic.
So what we're going to talk about today is I'm going to go over just an overview of the harness design process that we'd use at Caterpillar to include the integration of our Tier 1 suppliers into the systems, or leveraging our drawings for their manufacturing processes. Jason will talk about the software development process, and we'll show some use cases as we go through. And there should be plenty of time for Q&A. So at Caterpillar, when it comes to CAD data and Creo schematics, we use for diagramming, we use Creo schematics, and we use this process exclusively and use standard work for every product line. This helps us keep things consistent as we deliver that data to our engineering or to our material suppliers, and so that we can move data back and forth from all the facilities worldwide. So for Creo schematics, as an example, we do have a central catalog of symbols. There's about 5,000 to 10,000 symbols and about 30,000 part numbers in our catalog today. We do use each one of the phases in Creo schematics, creating a circuit or a block layout of sort of a routing diagram. We use the circuit diagrams for creating our subsystems, and then feeding that into our full wiring diagram for implementation to drive the harness designs. And Jason's team does write some custom applications to aid that, which I'll show you here in a minute. Then for the 3D design, we use the cabling package for routing our harnesses, the center line, spline, using networks and so forth. Again, standard work at every facility for every product line so that we can simply transfer data back and forth as we need it. And we use the custom applications for auto-population of data, design rule checks, and title block data. We take that 3D design, take it into the Creo manufacturing mode for flattening, straight out of the box today, but we've got some new tricks up our sleeves that I'll show you also. And then I kind of showed 2 blocks down at the bottom. It kind of diverges just a little bit. We do engineering drawings for release. This is our fully detailed engineering drawings, title block data, bill of materials, next higher level usages, and all that other things. What we've kind of gotten away from is using repeat regions to populate the tables in our wire to from list and other things, because our drawings got too big, and we actually found a limitation with repeat region tables a few years ago. So we moved over and asked Jason's team to populate the data more using static data gathering and fill into that information. And then for the manufacturing drawing, the differences are they need more visual aids and data extraction from the Creo models, and I'll give you examples of that. And then also the other big difference is the largest engineering drawings we use at Caterpillar is an E-size sheet. Well, I have harnesses that are 20 meters long in some cases, and so you have to scale them down to fit it on an E-size sheet or do other things, where the harness manufacturers need a 1-to-1 scale, and so that's one of the biggest differences there. So Creo schematics, like I said, there's a lot of functionality that PTC provides to us with the reports and some of the other checks that you can run. But where was lacking was our Caterpillar specific design rule checks. So we wrote those using the Java API that Jason talks about. And we also auto-populate data. So once we choose a data set, we can then use the API to populate mating connections, accessory information such as seals and wedges, and do functionality like that. Also, we wrote our own simulation tool. Nothing against what Jim has. We just need a little bit more, and so we had to write our own. Cabling package, again, straight out of the box for routing the harnesses using the networks. Then beyond that, again, more design rule checks. These design rule checks could be distances between splices inside the harness, wire gauge to connector compatibility. You name it, we try to think of different functionality. If you look here in the image here, all these green dots in the ribbon bar are all the different custom applications that we've written over the years. I don't have time today to go over every last one of them. It'd take me about 3 hours to go over those. And so we have, I just listed some of the highlights there. The flattening model for our Creo harness manufacturing. This is really truly right out of the box. We do the, flatten, create, or select start point, auto fan, move segments around, and so forth. Where we did customize it is auto population of title block data, so our PLM systems didn't complain too much. And then I'll talk about the form board drawing here in just a few minutes. Engineering drawing, I call it the easy button. If you create an engineering drawing straight out of the box, you have to choose your models, drop that view in, import your tables, manipulate data, move it around, and so forth. My easy button is basically a trail file. It drops everything onto the same location, on the same sheets, all the time. And then adds notes as needed as we go through. And there's some, then the design rules, or the final design rule checks are, do we have a note everywhere that a note needs to be? Or do we have all the tables that are need to be, or do they need to be updated at the right times? So part of the gist of this whole topic was the integration into the harness manufacturers. Many of our tier 1 suppliers at Caterpillar, when it comes to sheet metal, castings, forgings, they've used the Creo models for years. Caterpillar would give them the data, they would create their mold design or run the sheet metal part into their CNC process for the bends and cutting, the laser cutters and whatever else. When I moved into the engineering side, I worked in IT for 10 years. All we did was give our suppliers the engineering drawing, and it was really an image of the engineering drawing, a TIFF image. So they had to re-engineer our drawings in their own local CAD tools, AutoCAD, paper, and markers, you name it, and then extract the wire to from list manually. One supplier I went to one time actually had a team of 12 or 14 people sitting in an office reading line by line the wire to from list and loading it into their data. You can only imagine how error prone that was and how long it would take them to process the data. Some of our harnesses, like I said, not only are 30 meters in length, the biggest harness we have has about over 800 wires in it. So imagine, you get the idea of going crazy. So I said, why don't we give them the Creo models and let them extract the data and do what they need to do? So we polled all our suppliers, asked them what information they need, how they needed it, the one-to-one scale drawings, all the details and things like that. And then we also figured out how to give them access into our PLM database with security measures. So they only see the drawings that we allow them to see, and then they download the drawings and use the Creo tools for creating a color-coded drawing and data extraction into common delimited files. And so that gives them something like this, and then Jason's team also came up with tools for, one of the requirements they had was a wire insertion view of that connector that was color-coded. So that actually shows a blue wire going into pin 1, oh, lost the mouse, a blue wire going over here in pin 1 and a purple wire going into pin 2. So when they plot this on a one-to-one scale, they nail it up to a form board, see people nodding their heads, they could see, then they have that visual aid of what wires go into which cavities and what that wire ID is. And then also they do the shaded drawings so that they could use color coding on the bundles themselves or the segments. They have a choice of whatever color they want to use, but in this case, the light blue means there's no sheathing material. These are bare segments. And then the green is actually a black tape, fabric tape that gets around it in this particular case.
Okay, so like I said, I have a team of software developers who write automation using the Toolkit APIs. And so one of the things Frank and I wanted to talk about was what are the challenges from an IT perspective in understanding an engineering process and a process that needs improvement, and how do we use automation in the IT world to solve that problem. So we use many methodologies at Caterpillar. The one I'm going to talk about today will follow a Six Sigma style process. I'm sure some of you are familiar with Six Sigma processes, but we use various other ones at CAP. For the purposes of this demo, I'll use Six Sigma. So the first thing we do is we get together with Frank and his team, and we define the problem. The first step is always define the problem. And in this step, we tend to have a lot of people that already have some ideas how they want to solve the problem. They have various things in mind that they've had on their mind for a long time before the project starts, and they think this would be a quick fix. The define phase is where we want to just define the problem, the as-is process, and how it's lacking. We don't want to talk about any possible solutions that will come later. So after we've defined the process, we want to measure the as-is process. This is important, and it's a time-consuming process because we're asking guys like Frank to do what they usually do on a regular basis, but take some extra time and log some hours and write down some time and some steps that they use to do the process. So it can be frustrating, but it's important for several reasons. One is your project sponsors, the people who are actually writing the check for this automation. They want to see value. So the measurement process right now is important because it establishes a baseline. So we're going to compare against that later. We're going to see if we arrived at the value we were trying to hit. Also, a lot of times we find in the measurement process that as we measure the various steps, we find that there's some additional savings that can be found. Maybe we were really trying to target step 2 in the process, and we found out that steps 4 and 5 are extremely time-consuming and could easily be automated. So it's another important step in the process. And I would say out of the entire process, define and measure and possibly explore are the 3 biggest advantages to using a process like this. So then, obviously, we explore the various solutions. This is done more on the IT side. So we talk about, I have up there, there's more than one way to skin a cat. That's particularly true in programming. There's a number of ways you can always solve a problem. So we weigh the pros and cons. We do mock-ups. We kind of look at proof of concepts, little bits of code that tackle the process or tackle the problem and see which one we like best. And we always like to include the engineers, guys like Frank, in that decision-making process to make sure we're using the one that would work the best for everyone. So at this point, we present the solution and the proof of concept to our financial sponsors. One thing you learn pretty early on is you don't want to go ahead and spend $250,000 and then have a finished product and deploy it and say, well, there it is, I spent the money, hope you like it. You want to talk to them up front because now we have the problem defined, we know the solution we want to go with, so we know kind of what resources we're going to need, what money we're going to need, and the project timeline. So this is a good chance to ask for approval to move forward. So your presentation was super good, and they go ahead and give you the ability to go forward, and you get to develop the software. As a code development team, this is the most fun part. This is the easiest part. This is why we jump through all the red tape so that we can go through here and get to coding and solve the problem. This is the time, though, if you encounter any questions or if you're not sure, you didn't anticipate a problem, engage your subject matter experts. You don't want to go to them afterwards in the testing phase and they say, why does it work like this? And you say, well, I ran into this during coding and I just kind of made a decision. Always involve them in the decision-making process during the coding. And then test the solution. It seems obvious, but you got to test early and test often. You're not just testing for software glitches and bugs. You're also testing, is this going to provide the value that we were looking for? It might look cool, it might do some fancy things on the screen, but is it really going to deliver the value we were expecting? And then if you've gotten this far, you go ahead and roll out the solution. We send it out to all our various site admins who do the installs, and then we implement financial controls. So we use logging and monitoring to ensure that we're capturing the value that we intended to capture. And then we report back to our project sponsors with all the money we saved them, and they're super happy, and maybe we get promotions. So we'll go ahead and look through some examples of how we use the software process to develop some of our automation.
Well, you know, I'm glad you talked about that or mentioned that, Jason. You know, I was working the other day and flattening one of my harnesses, and you know, I noticed that I do this many times. There's about 5,000 harness part numbers or change level releases at Caterpillar each year across all our product lines. And every time we go to make a flatten model, I have to go file new manufacturing, give the file a name, and then choose my harness part, select the start point, click auto fan, do a couple other wait for regenerations and things like that. And so we got about 16 mouse clicks and 3 manual entries. Minus this regeneration time, this takes about 90 seconds. So let me show you what I'm talking about here real quick. And why it takes me, you know, it feels kind of funny to do.
So guys like Frank make it easy because he goes ahead and defines the problem for me before I even ask.
So I'm gonna give my harness manufacturer, or give my flattened model a name, choose my harness part. Now I'm going to go flatten layout, so select my start point, go in. We've all been there and done this. If you're used to the cabling process, I'm going to click auto fan. If I go into thick cable mode and zoom in, you know, now I've got to start to do the work to manipulate the bundles manually. So, what do you think, man?
Well, like I said, it looks like you defined the problem. We're looking at basically a bunch of mouse clicks, a bunch of manipulating the wires and things manually. A lot of this looks like it's following some sort of logic pattern where we could probably automate that task. So we went ahead and we started this project to create some sort of an auto flattening tool or a flattening assistance tool. And one of the cool things about this project is, like I said, the importance of the measure phase that no one seems to give due credit. Is we ran across a couple of challenges where how do you measure the time it takes to do a process like this when the harness complexities vary so much? I mean, we could be talking about a cable that has, you know, just a split on it, or we could be talking about a battery cable. It's pretty simple. We could be talking about a harness that has 80 wires in the bundle.
Yeah, you're right, because this basic process is about the same for all of those. You got to create the file and start somewhere.
Yep. So Six Sigma methodologies, there's some tools you can use to kind of set some tolerances as far as complexity of the harnesses, but we ended up coming up with a low, medium, high complexity for harnesses, and we measured the time it took to kind of produce flattened versions of those. And as we explored the solutions on how we might solve this with logic, we also started getting more input as the process always does, generates more ideas along the way. You know, what if we didn't just flatten these? What if we were able to select what size sheet or form board we want this to fit on? What if we don't want to do a complete flattening? What if we want to do a flattening from a particular start point, things like this? So we walked through the process. We eventually picked our solution, and here's what we kind of came up with. You want to demo the?
Sure. Let me close this out and clean up a few things. Not sure why I have a black screen, but that's okay. I'll go around it. I want to go into electric lines. Oh yeah, we installed the new software. I've got my create manufacturing model. It's going to ask me if I want to perform the harness flattening. What it's done is it did a file new manufacturing harness model, and it's now asking me to select my start point, just like I did earlier. Oh, here we go. So now it's done the file new, and it's now starting the auto fan process. So the harness has been flattened using the auto fan process as we do, but some of the ideas we also generated is that we do at Caterpillar is we change every dimension and move breakout segments and so forth to on a 90-degree bends and a small bend angle, so that we don't get the sort of the sweeping curves. We like our suppliers like the sharp bends, and so if I go into a full flattening mode, it's regenerating the model now, and it's doing some spatial recognition to make sure that our breakouts go into the right side of the segments. It's still regenerating here just in a moment. And if I zoom in, we now have all our bends on 90 degrees, very small bend angle to give that sharp crispness of the model. Is it perfect? No, but it gets me a lot farther than what I had before. And so now as an engineer, I could decide how I want to move these segments around or do some other data manipulation.
That's some added value of the process as well. When you're in your define the problem phase, these things tend to grow out of control sometimes. You can always think of something that it could do additionally. So
right.
Early on in the project, you have to set the scope. And once your ideas are locked down, I mean, we can do a Gen 2, a Gen 3. We can always come back and start a new reversion. But you want to make sure that your success factors are defined.
So we did do some measuring on this process, or this improved process, and based on that, the time savings, our detailers would save about 1,000 hours a year, and that each year as long as we use this process. One of the other things that we do is, like I said, our harness manufacturers like to extract the data, the wire to from list and the bill of materials from our tables that are in the engineering drawing. And there's plenty of ways to extract that data from a table, but it's not a very easy way. You can save the table to, using table CSV, then they have to bring it into an Excel spreadsheet, move the columns, manipulate the data, and so forth. So what do you think, Jason? Do you think we can make that easier for them?
And no idea, right? I'm an IT guy.
So, I have confidence in you.
I'm going to go through the process again. So the definition of the problem, essentially what we're talking about here is extracting the harness data in a way where we can export it to maybe an Excel file or something. Again, we shouldn't be saying that because we're not supposed to be talking about solutions, but we could export it to some sort of spreadsheet and we can manipulate it and send it off to maybe our harness suppliers or something like that.
Sure.
So one of the reasons why I like this project so much is because this is another perfect example of how the requirements can change and how you think you're going to start something simple and it can grow into something that's actually more complex but actually pretty cool. So the measurement process for this, it was pretty straightforward. I mean, we know how much time it takes to extract that harness data and get it into a spreadsheet or a Word doc. Everybody's doing this. But as we got into explore the solutions, we started to think, well, instead of tailoring this one certain way, let's make it customizable. Let's make you can extract this harness data, and then you can kind of save it in whatever way you want to save it first, so you don't have to do all this manipulation inside of an external spreadsheet solution. And then we started thinking, well, if you're going to have this interface to customize all this data right there in Creo, why not have the ability to filter some things in and out, and why not have it all populate right there on the screen? Well, then we started to think additionally, this isn't just good for exporting, it's also good during the design process, because you can actually pop up all this harness data real time, manipulate it, see what you're looking for right off the bat. And so instead of having just a simple export tool, what we ended up coming up with is something that's aids in all the phases of the design, and is actually a pretty neat GUI tool.
So Jason's team is actually in the middle of developing this tool right now. But what they've got is an easy-to-use interface, very similar to the parameters display that is in the cabling mode. So I don't have a live demo on that piece right now because this is kind of a mock-up. But what the users and what the team decided on as a requirement is this report generator will come up. The users could choose what columns of information they want to display, what order they want to display that information, and we have it tabularized, information about the connectors, information about splices, the wire to from list, you name it, we could put any kind of tab that we want. And once we have these formats saved on the that I as an engineer, if I want to look at the data in a certain way, I have that choice of picking that information up. The suppliers who want to extract that information, they can have different templates. And they save those templates on their hard drive and use them over and over again for every harness that they may be processing. And as Jason was saying, I could have this window up on a separate screen to look at the data, go back, change the data or parameters, refresh it, make sure that I've got the same seals for the same type of connectors, and other data manipulation. And then when I'm ready, I can hit the export button, out spits my spreadsheets, and I can put them in my reports, give them to the supplier, or the suppliers can load them into their manufacturing processes. In summary, with the software process and with the data flow to our manufacturers, you don't want to skip any steps. You want to make sure, on the engineering side that we've got security in place, your suppliers understand what models they're going to be getting, and even you might have to train your suppliers. They're used to AutoCAD, you got to train them on Creo. Sometimes there's a few hurdles there about how to get over those steps. Software side, they've got to, you need to not skip any of the development process. Engineers, we're always, burdened with time. I don't want to take my measurements, or I complain about, measuring my own processes and the mouse clicks that I have to go through. But it does pay off in the long run, especially when you talk about spending money to developing these applications. You need to show that you're saving those, at least that much, if not more, that you've spent to develop the applications. You want to listen to those users and customers, and on those requirements, and never put down any ideas about what may come out as you're listing those concepts. And then finally, test your solutions before your deployment, and then just repeat the process over and over again. Caterpillar started using Pro Engineer back in 1992. Electric line specifically for harnesses started in 95, so we're at our 20-year mark on this part. We're pretty successful at it, and we think everyone else could be successful at it if you just put your mind to it. With that, any questions? Yeah, there's several out there, Kat. Go ahead.
When you flatten them, when you flatten your cable, is that what you're using to form? When you flatten the drawing, is that what you're using to form as your form board?
Yes, the flattened model does become the flattened view on the engineering drawing and on the form board. And usually that flattened view is the same both on engineering and the manufacturing drawing. We've negotiated with our manufacturers to work on, the way we have it laid out on the engineering drawing is the way the form board needs to be laid out, because sometimes our bundles are almost 75 millimeters in diameter. You cannot put the breakout on the wrong side, because if you have to wrap it around, it won't reach. So we've got to be very particular how we lay out our harnesses.
And do you use paper, Mylar? I mean, are you concerned about any kind of shrinkage, or is the cable so big that?
What kind of sheathing material we use?
Yeah,
on our
what kind
harnesses?
of, so when you print out, you actually print these flat?
We leave that up to the harness manufacturer. Some of
Okay.
them do use Mylar, clear Mylar sheets, and they'll mirror that image, so they turn it over so they don't rub the ink off.
I see.
Others use paper. It's really up to them. I've taught, usually plotters will do both, so they just need what kind of tools would they have available for plotting that off on a one-to-one scale.
Now, do you also, when you design that, do you do it in color, so it's color-coded for that reason? Or is that all in the table and you're not too concerned about
Actually, some of that color coding that you see today, I use internally to make sure I've got the right sheathing material in the right places on my engineering design. And when I work with my tier 1 suppliers, I teach them how to change the colors the way they want them, on their board. So it's straight out of the box, the color appearance or the.
Thank you.
I had a question about rigid harnesses. So most of your harnesses you can flatten out so they're perfectly flat.
Right.
But do you also make rigid harnesses for the case where the bend radii are, it's not flexible enough to meet the bend radii? And,
We do have a few product lines that have rigid harnesses or steel conduit. In those cases, we do a harness drawing that has the wire links and things like that, and then they'll have a separate drawing for how it goes into the conduit, if that conduit's all bolted together. So that's usually like a next higher level type drawing to show them the type of connections and to give those kind of visual aids for the manufacturer. But that's only a few industrial cases on our large Kiel, they're out of Kiel, Germany, but they make large container ship engines or so that has that kind of conduit. So it's not a big portion of our data set.
So in referencing your harness vendors, do you guys produce your own harnesses as well as outsourced to Tier 1?
Over 95% of our harnesses are outsourced today. We had a facility years ago that we shut down, and then a couple of months ago we acquired a new company that had a harness facility. So now we're kind of, but they're doing like just genset cabinets at one facility right now.
Okay, so then in the same regard, whenever you start talking about your manufacturing drawing, that's where you communicate with your Tier 1 supplier, right? So in that regard, did Caterpillar define their own standard and drive the Tier 1 suppliers to adopt whatever that method was, or did you develop that method with the harness vendors in mind?
We do use, it's a little bit of both. We do have our, we call them 1E specs that go into our title block data. The standard that we want those harnesses built, the minimum standard that we want them built to. And so when we're negotiating with them, you know, can you build harnesses to a new supplier? Can you build a harness to this standards? And if they say yes, then we test them on that. And if they exceed the test, great for us. If they don't meet it, then we need to find out why they can't get to that point. And we do have interactions with our suppliers on what may or may not work for a particular application. And so, you know, we do have those ongoing negotiations with every product line and every supplier.
And then lastly, when you guys do kind of a first article inspection or running PPAPs or any kind of incoming quality checks like that, where does your quality department check? Do they use both the engineering drawing and the manufacturing drawing to check a vendor's quality, or do they stick with a certain set of documentation out of all of it?
It depends on the supplier. Some of it has to do with we said PPAP, but it's the same naming convention with us too. Before they build, sometimes they'll show us their image of the form board drawing just to make sure they've made the form board drawing to our or where we think the breakout should be, and dimensionally is that right? But finally, you know, when they deliver the first piece, then we'll use the engineering. The engineering drawing is the key. It's what the PO is calling out and everything else. So that's what they're held to, is that engineering drawing.
With regard to your customization, my company tends to frown on customizing CAD tools simply because CAD tools change. How often do you have to go back and rework your stuff to integrate with the new versions that come out?
Yeah, that's fine.
Okay. I was going to say, funny you should mention that, because this year we're actually starting a pretty big initiative to go back and rewrite a lot of the things that we wrote. It was right about 10 years ago, I think.
Mm-hmm.
So our electric lines base product is about 10 years old, and so we're going through a rejuvenation of that project, or of that tool. And so a lot of that will be either rewritten or changed, or you know, some things that we don't use anymore we'll remove from the tool. But a lot of the projects that we kick off, we do Gen 2 versions. So we'll start with a pretty simplified set of tools, and then we'll go to a version 2 that has tweaks and add-ons and things like that. So
I would also add on some, Jason's fairly new to the software, or I call it my software team because, you know, they develop stuff for me to make my life easier. But every time we go from a new version of Creo, we moved from Wildfire 4 to Creo 2 a couple years ago. And so we actually use the Six Sigma methodologies for the deployment of a new version of Creo. And so we go through, and we may not necessarily measure, but we have a list of test cases. So when we get, new version of the Creo software, they'll compile it against the latest toolkit, first see if it breaks, and then if it doesn't break, does it still act like it used to, or if it needed to change. So there has been times when it's not even, whatever was the predecessor to the toolkit, the latest Creo toolkit, some of those function calls go obsolete, so we have to find a new method and update our code to match that.
Have you looked into providing wire links?
Providing wire links
Yes.
to our suppliers.
Individual, yes.
We use whatever wire length Creo comes out, all our wires are packed in the harness. So what I was showing you here is a fully packed harness assembly. The wire to from list is all in here, and the links all come straight out of Creo into the engineering drawings. So we don't use a third-party tool. It's all embedded. We don't go in and out of other applications that way. So the wire links are built into the model. That goes right into our wire to from list, and we don't come up short. I mean, if we come up short, it's usually because we put a brake on the wrong side or something like that. But the centerline links do a good job for us.
So they use that cut length to cut their wires.
Right, yes.
Oh, okay. And who exports the reports, what you were showing? You do, or the harness manufacturer? I mean, they might want to have a different list or different order or something.
Right, so when we'll give the models to the harness manufacturer. I also we give them a copy of our custom tool software that runs inside of Creo Parametric, just like I use. It's just a different mode of, as they're in the drawing mode. So they extract the information how they want to extract it. I do, like I said, so most of that, I make the harness manufacturer responsible for that. And they look at the spreadsheets, and they can look at the engineering drawing that they're legally bound to print, build to, and they'll see that the links are the same at that point.
Hi, this is about the usage of the 3D models.
Yes.
You put all of the models inside of your CAD products. What techniques do you use for large assembly management?
Large assembly management, you're talking about like top-down modeling, or how we build the...
Yeah, do you use simplified reps, motion skeletons? How do you diversify in your product to share your content and not burden every PC?
Yeah, most of the time we do build lightweight or skeleton models sometimes in our harness assemblies, just to show the surfaces that we are referencing to the for the harness design, such as clipping points and so forth. But typically, now that 64-bit operating systems and gigabytes of RAM and stuff like that, I can open on that large wheel loader. I mainly do the operator station or the cab, and I'll open that entire cab and get pieces that I want, or I'll route right in that model. But then I'll break dependencies to that cab by redefining my location points to an offset coordinate system, so that I don't keep those parent-child relationships as I finish up my design. I may keep those references in my initial design, so as fluid as things change sometimes early in an NPI cycle, I'll keep those references, but I always break them before release. And that way, if you don't know, Caterpillar uses Team Center, not Windchill, to hold all our data. Windchill's a little bit more finicky about how it keeps those references, and I don't want to have to pull down an entire machine just to open a harness, so it could be finicky. One or two more questions?
Anyway?
Let me get back to the presentation here real quick. So I appreciate your time today. Your feedbacks are valuable to us. I think there's going to be some sort of feedback about all the presentations. Any of them that you see, feel free to let us know how we did. And if you have more questions, I'll be out in the hallway afterwards. So thank you for your time.